In this example, we're going to solve the following integral using integration by parts. We have the formula for integration by parts there, so we're going to apply the formula, and as it says here, we need u and dv in order to begin this process. So we're going to choose u and dv so that we have something that's easy to differentiate and easy to integrate. The easiest term to integrate there is e to the minus x dx, so we'll choose that for dv, meaning the integral of that is e to the minus x, but we need negative. Sine 2x is left over, so that's what we'll take the derivative of, or that's u, and that means du is the cosine of 2x times 2, or 2 cosine of 2x dx. Using the formula then, we'll put in the pieces, so we get u times v, so minus e to the minus x times the sine of 2x, that's u times v, minus the integral of v du. So v is minus e to the minus x, and du is 2 cosine of 2x dx. So we've plugged in the formula, and that's what we get. Well, this integral here we can clean up a little just to make this look neater. So this is minus x sine 2x. We have a minus, and a minus means plus, and we have a 2, so that'll be plus 2 times the integral of e to the minus x cosine of 2x dx. And right away, hopefully you notice that's pretty much the same question, except we've replaced the sine with the cosine, which means the solution is going to come from integration by parts. So continuing, again choosing u and dv and applying the formula, well, we're going to choose dv again to be minus e to the minus x dx, meaning v is going to be again minus e to the minus x. U is going to be cosine this time of 2x, meaning du is going to be the derivative of that, which is minus 2 sine of 2x dx. Applying the formula again, we get this part staying the same. This is the part now we're working on, so that's going to be plus 2 times, and now we're applying the formula, so u times v minus e to the minus x cosine of 2x minus the integral of v, I'm going to put these in brackets, and du. So we end up with this mess here. So let's simplify it, see if we can't get anywhere. So we rewrite this, we can multiply this through by 2, we get minus 2 e to the minus x cosine of 2x. Minus with minus is plus, but there's another minus, so it stays minus. We have a 2 here and a 2 outside, means it's going to be minus 4 times the integral of e to the minus x sine of 2x dx. And either one of two things happens when you see this. You either say, oh, we have to do it again, and you get completely frustrated because you realize it's just going to repeat, or you notice that's the question. We've actually got the same piece down here. That means, since this is an equality, this is always on the left-hand side here, and if I write it, hopefully you can see what we're going to do. Here's the left-hand side. We just usually don't write it the whole time. And we're going to take this term and move it to the left. Here it's minus 4, so over here it's going to be plus 4 times the integral of e to the minus x sine of 2x. And the right hand side then, minus e to the minus x sine of 2x minus 2e to the minus x cosine of 2x. On the left we get 5 times the integral of e to the minus x sine of 2x dx. We should add those dx's up here. And that's going to equal, this part's going to stay the same. Now you notice we have 5 of these. To remove the 5, we divide by 5. So we end up with the integral of e to the minus x sine of 2x dx is going to equal 1/5, the dividing by 5, of all this. So we'll just put it in brackets. So that stayed the same, and we add plus c since it's an indefinite integral.